And you can always take a picture of the board instead of taking notes down. I was waiting to see if anybody actually did that. Yeah, last year at Ocean, when I was at Ocean, I'd fill the boards with notes, and students would not take notes during class. They'd listen, and then at the end of class, they would come up and take the whole board was filled with students standing in front of the board, snapping pictures on their phones of the board, of the notes. Then they would refer to them later. Yeah, weird, huh? Yeah, it's like weird. Anyway, they did that several years, maybe 4 or 5 years, when kids started to have cell phones. Right. So we're going to start to classify elements based on behavior. What Chapter 6 does is it gets the student ready for bonding by paying close attention to the valence electrons. Now, what we're going to look at here, can you hear me? Nah. Okay, sound check is, that's the most excited I've seen Ahmed in months. Excellent. Okay, so this is going to be second period, the second period. The horizontal rows are called periods, okay? The vertical columns are called groups. Very good, groups. And these groups have names. They're also called families, the halogen family, yes? There are horizontal groups that have names, but they're actually groups of vertical columns, not necessarily horizontal rows. For instance, I know Dylan's looking at me like, what does he mean by that? That's like a puzzle of some sort. Well, the transition elements are certainly horizontal, but it's not the entire row, right? Just that those middle group of columns, the D elements, the rare earth metals are the Fs. Clear? Okay. So, and some of the heavy P elements have transition metal properties, such as lead, which is actually a P. What is the NLX for lead? 5, 6P, 5P? What is it?
6P2.
6P2, yeah. So lead, you know what lead is, right? Yeah. So lead can have some, you know, when you think of a transition metal, what do you think of? A metal, a classic metal, yeah? Like sodium is like a vanilla taffy, you know? You know what taffy is? Is that like an American thing? You know what, you ever hear of saltwater taffy? Really? You know what saltwater taffy is from Texas? Yeah. That was invented, I think, in New Jersey, I think, saltwater taffy. But anyway, it has nothing to do with salt water. It's just taffy. What would you call it, Dylan? Taffy. What would you call it?
Saltwater taffy?
No. Yes, thank you very much. But Lauren doesn't know what taffy is.
Oh, it's like candy. It's like caramel.
It's like a.
It's not caramel.
It's not. It's different flavors, and
Strawberry, banana.
it's thick and chewy. It's like a really, 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 really firm
Candy.
caramel.
It's made of caramel and it's called salt water.
No, it's not.
No, was that? No, you know what caramel is?
It's heated
Yeah.
up sugar.
Yeah, heat up sugar kind of thing, but it has different flavors. Very, very popular on the Jersey Shore, saltwater taffy.
What's saltwater?
Kind of chewy. It's like gum, but it's not gum.
What's saltwater taffy?
Because it's made near the salt water, I guess. I don't know. It's
What
a.
here?
It's
Sophie.
salty and sweet at the same time.
No.
Coffee. We have that here.
It tastes like banana.
You have saltwater taffy here?
No, we don't call it saltwater taffy, we call it toffee.
You call it toffee?
Toffee.
Oh, toffee. Yeah, toffee. Yeah. That's a British version is toffee. Yeah. Okay, all right, I got you. You know what toffee is. Yeah. Okay. We've solved the problem. We had a... You get a group of international kids together and they don't understand things like toffee and coffee and... It's hard to identify where I come from. Well, the United States, but where in the United States, unless I say COFFEE.
Oh.
I say it with a New Jersey accent.
Coffee.
Coffee. Or if there's a DOG bothering me, the dog is barking, you know? You talking about my daughter? Huh? You talking about my daughter? That's a New Jersey accent. Okay, so what we're going to look at is we're going to look at something called ionization energies. Now, listen carefully. Ionization energy is the energy needed to remove the outermost single electron. The second ionization energy is the energy needed to remove the second most outer electron. The third ionization energy is the energy needed to remove the third most outer electron. The fourth ionization energy is the energy needed to remove the fourth outermost electron. But what we're going to look at the first ionization energy. Now, we have identified before what the first ionization energy level affects. And that's the outermost electron. How have we named the outermost electron? NLX, right? Right? The quantum numbers, right? So, what is the outermost electron for lithium? It's going to be 2s1. What are the quantum numbers for lithium? Just very quickly. They're all going to be 2, right? Right? That's N, right?
Yes.
They're all going to be 2.
0 for
So for S, it's going to be 0. For P, it's going to be 1.
and it's plus.
And for M, it's going to be 0 for S, right? And then
Plus.
-1, 0, +1, -1, 0, +1, right? And then +1/2. I'm not going to put the 1/2 in. You all know it's 1/2, right? Okay. +1/2, -1/2.
Plus.
Then plus,
Plus.
plus, minus, minus. Okay? Easy? Yes? Okay? Now, so let's put the electrons in the orbitals. Yes? Yes? Yes?
How come over there it says plus?
Because that's a mistake. Excellent. I like the fact that you noticed that. Okay, so this is going to be like this, right? This one is going to be like this. Yes? Then it's going to go like this. Correct? Yes? Then we're going to go... What rule am I following? The off-bow rule?
That's from, there's another one.
There's other rules. Off-bow rule.
Pauli's
Pauli's exclusion principle. What else? Hund's rule. We're doing all three at the same time, right? Then we're going to go... Yes? Are you with me? Okay. I have torn rotator cuffs. It really hurts to write on the board like this. What else? Where's the other one?
The first,
Yeah.
Is that it?
yes.
Okay. I'm going to turn around and do this. Back of my neck, it looks like a Florida manatee. The students used to call my back of my neck a Florida manatee. If you ever look up what a manatee looks like, that's what a manatee looks like right here, okay? It's an endangered species of aquatic animals, marine animals in Florida.
How does it look like a manatee?
When you look up a manatee, you'll know.
I know what manatee looks like.
Yeah, I know how to do it.
First of all, they're being silly.
Oh.
Okay, so that's where we stand so far. So, let me get something here. So that's where we stand. So what I'm going to do is, I'm going to outline the last electron, the one we're going to take out, in red. Oh, that's not right. Okay, now, which ionization energies do you think, just using your intuition, would be the easiest to remove? Which electron would be the easiest to remove? Any ideas? The ones in red. Well, those are the first ionization energies. Maybe not the easiest, but which element of these 8 elements, which one would be the easiest to remove?
Lithium and
Lithium would be.
Yeah.
Okay. And what about the hardest to remove?
no fluorine. Neon you can't remove.
Yeah, 'cause
Neon you can remove, but it's very, very hard. The ionization energy will be amazing.
so it's you.
Okay, it would be amazing, the ionization energy. Okay, all right. So now we have everything. Now what we're going to do is we're going to approximate, we're going to try to guess what these ionization energies will be relative to each other. Okay, relative to each other. Yes? And then we're kind of going to graph them here. I'm going to put on the board some data. So when I come back for the next video, we'll actually graph the ionization energies for period 2, just those 8 elements. Are we ready? Did I set everything up? Okay. So that's ionization energies part 1. Look for that in the funny papers. Okay. All right. Ahmed, I tell you, he's like laughing today. I like that. Excellent.
No, not.
Excellent. Well, you're always smiling. Stop smiling.